Okay, so here is the 2019 free response. I would, this is a partial part of the question. I've only included D through G because this is applicable to this unit. A, B, and C obviously were parts from previous units, and you can access that full question from the email that I sent earlier this morning. So if you want to push pause and try this, and then we can walk through and kind of show you what to do from here on. Okay, so the compound BrCl can decompose into Br2 and Cl2 as represented by the balanced chemical equation below. And so obviously they give you a balanced equation. They also give you a enthalpy of the reaction. And remember, because this is positive, okay, that means that energy is absorbed. Okay, so if they do a Le Chatelier's type of question later on, you might have to kind of think about that, but I don't think they do on this one. Okay, so a 1 mole sample of pure BrCl in the gas form is placed in a previously evacuated 2-liter container at 298 degrees Kelvin. Eventually, the system reaches equilibrium according to the equation above. Okay, so D, calculate the pressure in the container before equilibrium is established. Okay. E, write the expression for the equilibrium constant for the decomposition. You can either write K equilibrium, which is basically Kc, K with concentrations, or Kp. And we'll talk about that a little bit in here in a minute. Okay, after equilibrium has been reached, 42% of the original Br sample has decomposed. Okay, so F, determine the value of the equilibrium for the decomposition, and then G, calculate the bond energy of BrCl bond in kilojoules per mole using the delta H of the reaction. Okay, so let's go through this problem. Hopefully I left enough room, and of course I didn't, so let me add a page. I officially should know how to add a page. I just went through it. Add a page. Perfect. Okay, so that'll be kind of below that. Or not. Add a page. There we go. Now it is. Okay, so let's start with D. Okay, and I'm going to zoom in here. Okay, so D is asking for us to calculate the pressure in the container before equilibrium rate. So this is just a simple Pevnert problem. Okay, if we're going to solve for pressure, in RT over V. Okay, and so we've got 2 moles. R, let's go ahead and use the universal gas constant. You can do the units. 298 Kelvin. Okay, that was given. And then our volume is 2 liters. Okay, so that was kind of easy peasy. What you should get is 1.22 ATM. By the way, this was 1 point, okay, for this question. Okay, I'm going to do the next one in a different color. So E, let's look at what it asks for us. Let's look at what it asks for us to do. Okay, E, it says write the expression for the equilibrium for the decomposition. So on this one, you can either write the equilibrium expression in terms of concentration, okay, or partial pressures. They will give you credit for both. Okay, so I'm going to do a big fat or. Okay, Br2 it's doing that funny thing where it corrects my lines for me. Don't correct my line. Okay, and this was 1 point. Okay, so let's go on to F. Once again, that's pretty easy peasy up to this point. Okay, so F. Let's go back and read the problem. After the system has reached equilibrium, 42% of the original Br sample has decomposed. Determine the value of K equilibrium for the decomposition. Okay, so here we're going to do a Rice table. Okay, Okay, so this one's a little bit longer, so let's write our equation. Okay, let's fill in everything. We know that we're going to use partial pressures here, okay? So at the initial start, 1.2 atm, 0 and 0. Okay, now, because 42% of BRCl has decomposed, we can subtract 0.42 of 1.22, okay, whatever that is. And we know that because this is 2, this is 1 and 1, that we're going to add half of that, so 0.21 times 1.22. And my kid just woke up, so bear with me. You might hear him in the background. Or my dog. I don't know which one. Plus 0.21 times 1.22. Okay, so let's go ahead and calculate the equilibrium change. 0.71 atm, 0.26, and 0.26. Okay, so this right here would be 2 points. Those are the equilibrium concentrations. Oh, we gotta do the equilibrium. Okay, so let's plug these values in. 0.26, 0.26, 0.71 squared. You get an equilibrium constant of 0.13. That would be worth 2 points. Okay, last but not least is going to be E. Switch colors. Once again, you might hear my kid come in. Okay, and so the question is asking, calculate the bond energy of the BRCl bond, okay, using the delta H for the reaction and the information. Okay, so this is going to kind of review some of the material from last unit. We know that delta H is related to bond energy of what's being broken, and we're going to subtract the bond energy of what's being formed. I know, baby. Hey, there's a blanket right there, baby. Get that? I got to finish up this video real quick. There's a very, very top blanket. Yep. Okay, and so if we use this data, let's think about our reaction. 2 BRCLs, okay, yields Br2 plus Cl2, okay? And so if we plug in all the values that are given, let's think real clear, okay? Delta H is given, so this is 1.6 kilojoules per mole, is equal to the bond energy of the bonds that are being broken. And so think about what's being broken here. There's going to be 2 BrCl bonds broken. We're going to subtract that from the bonds that are being formed. Okay, and so what's being formed is a Br to Br bond and Cl to Cl bond. Those you add together. And so now we just plug everything in. Okay, 1.6. Okay, 2 to the x, and if we go back to our table, okay, all of these are here. We're trying to find, ultimately, this value. We're finding x. Okay, minus 193 plus 243. And so if you go back and solve, x here is going to be 219 kilojoules per moles. And that would be a 1-point problem as well. Okay, so next video we're going to look at heterogeneous equilibrium, as well as what happens if